At last, Voyager 1 slips into interstellar space. Vertical line Atom Cosmos Vertical line Science News. Subscribe Archives Register Log in. Atom Cosmos. Body Brain. Earth. Environment. Genes Cells. Humans. Life. Matter Energy. Molecules. Science Society. Other. ESN Kids. 09 Vertical line 21 Vertical line 13 Issue. Contents Collision Course. Scientists struggle to make windows safer for birds. The Tune Wreckers. Lousy singers make the pitch for scientific relevance. Subscribe. Give a gift. Renew. RSS feeds. Email alerts. Digital edition. Podcast. Past issues. Read articles, including science news stories written for students, on the SNK website. Contents Alien cart leap onto the scene. Invasive fish break people's bones and threaten native species. Video games. When Granddad wins. With some practice, people over 60 bested untrained 20-year-olds meet the new meat. Scientists made a hamburger without harming animals, but it cost as much as a house. Home Flash News. At last, Voyager 1 slips into interstellar space. Solar blast data provides definitive evidence that spacecraft has cruised beyond the Sun's clutch. By Andrew Grant. Web edition, September 12, 2013. A+A, text size. Solar blast data provides definitive evidence that spacecraft has cruised beyond the Sun's clutch. By Andrew Grant. Web edition, September 12, 2013. Enlarged. Interstellar Wanderer. Voyager 1, launched in 1977, crossed the border into interstellar space on August 25, 2012, according to a new study. Credit, JPL Caltech/NASA. Humankind has officially extended its reach to the space between the stars. NASA's Voyager 1 spacecraft exited the vast bubble of particles that encircles the Sun and planets on August 25, 2012, mission scientists report September 12 in Science. At the time, Voyager was about 18.2 billion kilometers from the Sun, or nearly 122 times as far from the Sun as Earth. This is the beginning of a new era of exploration for us, says Edward Stone of Caltech, who has headed the Voyager mission since 1972. For the first time, we are exploring interstellar space. Confirmation of Voyager's interstellar exploits came after determining that the probe is surrounded by a relatively dense fog of galactic particles rather than a thin mist of solar ones. It was a tricky measurement that required patience, clever detective work and heavy dose of luck. NASA launched Voyager 1 and 2 in 1977 to explore the outer planets, but from the beginning Stone's team hoped the probes would survive long enough to investigate the region of space where our star's dominance finally wanes. The Sun unleashes a flood of hot, charged particles called plasma that jets out in all directions. The plasma forms the bubble called the heliosphere that is tens of billions of kilometers in diameter. Over the last decade, the solar plasma around Voyager 1 has thinned as the spacecraft hurtles toward the edge of the bubble at more than 60,000 kilometers per hour. Astronomers have been waiting for Voyager to cross this boundary, the heliopause, where solar particles give way to even speedier particles ejected by other stars, and enter interstellar space. The first evidence that Voyager had reached that boundary appeared on July 28, 2012, when the number of solar particles measured by Voyager plummeted. But the particle count rebounded a few days later. 3 similar BIPs and recoveries occurred in the following weeks until August 25, when solar particles disappeared for good. ESN Online, June 27, 13. The solar particle measurement, combined with a surge in higher energy particles from other stars, suggested the Voyager had exited the heliosphere and reached the promised land. Several well-publicized studies made that claim. Stone and his colleagues resisted that conclusion. They lacked evidence of what they thought would be the key signature of interstellar space, the shift in the direction of the magnetic field. Solar plasma produces a distinctive magnetic field because it all comes from the same source. Scientists expected that the field would shift in interstellar space, where particles flit around in all directions. Despite the particle evidence that Voyager had departed the heliosphere, the magnetic field direction remained constant. We felt we did not have the smoking gun to say that we had left the solar bubble, Stone says. What the Voyager team needed was another independent measurement to confirm the story implied by the particle data. One option